Apex is a top-level Apache project, and it's totally open source. It actually includes two pieces. One is Apex Core, which is the core platform itself. And the second is a library of what we call operators that considerably simplify the process of building an application. So Apex is targeted at building distributed applications that run on a cluster. So your application effectively consists of many small pieces, each of which is an individual application in the traditional sense, and it runs in its own JVM, potentially on its own node in the cluster. And all these pieces are talking to one another to accomplish the objective of the overall application. One of the main applications for Apex, the main target areas for Apex is streaming data. And streaming data differs from batch processing in the sense that the data has no beginning and no end. Data is constantly streaming in and needs to be processed on the fly. A couple of examples of streaming data. One is data coming in on an IoT stream, Internet of Things. So if you've got a power company that has a windmill farm, for example, there's around 200 sensors on each windmill, and all of those sensors are constantly sending data back to the gateway. So that's an example. Another example is a clickstream. So if you've got a popular website that's viewed around the world 24/7, there's going to be people clicking on your web page in various parts, and those clicks again come back to the web server, and you need to analyze them potentially on the fly as the data is coming through to make dynamic adjustments to sales and marketing campaigns, for example. Okay, with that introduction, let's get started. Here's the outline of what we'll be covering today, the main concepts that come into play when you need to build an Apex application. Then we move on to a brief description of the particular application we'll be developing today. It's called the sorted word count application. And then we'll do a hands-on demonstration beginning with showing you how to clone the source repository for the Apex source code, and then how to build it. And then we'll move on to creating the process of creating a new application, and then eventually to running the application. And if time permits, we'll do a brief walkthrough of some of the code and the configuration files for the application, and also take questions. Okay, so the main concepts involved are operators, ports, and streams. So applications, as I mentioned, are built from operators, and an operator simply implements the operator interface. Each operator has input and output ports. So these are not TCP ports. They are concepts internal to Apex. They're just classes that encapsulate a stream of data that's either coming in or going out. The streams, the output streams of one operator are connected to the input streams of a downstream operator, one or more downstream operators. Developing an operator is somewhat simplified by this base operator class, which is already provided, and it provides empty implementations of all of the required methods in the operator interface. You could, of course, directly implement that interface if you like. Within an operator, you'll need to define whatever input and output ports the operator needs as fields within the class. Here again, default input port and default output port classes are provided to simplify that process. Finally, you have the main application class, and this class needs to implement the streaming application interface. That interface only has one method called populate_dag, and inside that method you'll have code, very simple code actually, to invoke the constructors on the operators to create new instances of those operators, whatever operators your application needs, and then adding streams to wire them together, output port to input port, to form the entire application. So that's actually the easiest part. The harder part tends to be deciding what operators you need and whether to write them from scratch, or more typically just using the existing operators in the Malhar library, or possibly extending them to tweak the functionality in some way. These applications, they process data within time-based windows. Typically, the default is half a second, 500 milliseconds, but that's configurable. You can change that to whatever you want. And I'd like to emphasize that these time-based windows don't introduce any artificial latency. In other words, you don't have to wait for the end of a window in order to process the incoming data. So the incoming data, we typically refer to it as tuples or events, and as they come in, your application or your operator is able to process them and send any resulting output tuples out the output port. The window boundaries are just marked by callbacks named begin window and end window, and those are just used for bookkeeping, and you don't actually need to do anything in those callbacks if you don't want to. Okay, so the application we'll be talking about today is called the sorted word count application, and there's 5 operators involved. Line reader, which reads files that are dropped into an input directory. That directory is being monitored by this operator, and then it outputs lines on its output port. The next downstream operator is a word reader, which splits each incoming line into words using a regular expression. Then we have a window word count. This operator computes the word frequencies for all words in the lines processed in the current window. So this is an example of an operator that chooses to wait for the end window before it sends those counts out. File word count is the next operator, and it accumulates all of these word counts coming from window word count and merges them into a map that it maintains. And then finally, it gets notified that an end of file has been reached, and at that point, it writes out the final sorted list. So it'll take that list that it has at that point and then sort it by the frequencies, and then emit it on the output port. And the final operator is the word count writer, which knows how to write data to an output directory. So it will take that list and simply output it to the output directory. These operators, I mentioned that they're connected to one another, the connections need to follow an acyclic pattern. So the graph that's formed should not have any cycles. So here's an example of the graph. We call it a DAG, which is an abbreviation for Directed Acyclic Graph. And this is what the DAG looks like for our application. We have line reader, sending lines to word reader, sending words to window word count, which sends frequencies to file word count. And notice that file word count has two input ports, one to receive the word count data itself, and the other one to receive a control tuple from the first operator to indicate an end of file. It then writes the resulting word counts for a single file to the writer. Okay, so with that, I'm going to move on to the hands-on portion. Here's a virtual machine that I've set up on which we'll be doing our work today. Let me just clear the screen here. The platform that I'm running on today is a laptop running Windows, and on that I've installed VirtualBox and created a virtual machine that's running Ubuntu 16. So, excuse me, if you run this lsb release command with the -a option, it'll show you what version of Ubuntu is being run. There you see 16.04.1 LTS. What we'll do now is we'll create a new empty directory called work, and we'll do all of our work there. So mkdir work will create the work directory, and then I can step into it, cd work. And if I do an ls, well, there's nothing there, which is to be expected. Now we need to download stuff from 3 repositories. But before we do that, let me mention some prerequisites. You have to have Java installed, not just the Java runtime, but also the JDK. So if you type java-version, it should show you the version of Java. To verify that you have the JDK installed, you should also type Java C-version. So Java C is the Java compiler, and if you just have the JRE installed, Java C will not be present and you won't see this output. Okay, so you have to have Java JDK installed. 1.7 or 1.8, either one works. And you also need to have Maven installed. Maven is the build tool. And Maven is MVN, and you do -- version, and it should show you the Maven version. And finally, you need Git. Git is the version control software. So if you do git -- version, it should show you the version of Git that's installed. So if any of these are not installed, you'll need to install that before proceeding, because the stuff we're doing today won't work without those prerequisites. All right. So all of this code is hosted on GitHub. And the way you clone a repository is by saying git clone and then the URL. So if we go to GitHub and go to this particular URL, Apache Apex core, That's the URL, https://github.com/apache/apache core. That's the core platform. So let's copy over that URL and paste it over here. If we do that clone, we see that Git is going ahead and pulling the data down. And it goes pretty fast because this one doesn't have all that much data. Now if I do an ls, you see there's a directory called Apex Core that has that repository. Let's do that again for the Malhar library. So we do the same thing, except instead of Apex Core, we use Malhar. This one can take a little bit longer because it has many more files. While that's ongoing, let me go to a different GitHub repository. We go to github.com/DataTorrent/examples. You'll see these elements in here, and the part that's useful today is this subdirectory called tutorials. So if you click on tutorials, you'll see there's a large number of subdirectories within it, and these are very useful when you're developing applications because they're small standalone example applications showing you how to do various things on Apex. So a large part of what an application does typically is pull data from some external source. So we have applications that show you how to pull data from Cassandra, pull data from HDFS files, pull data from JDBC data sources, JMS data sources, and so on and so forth. So depending on your use case, you might find something here. There's actually a very good chance you'll find something here that is directly useful to your particular use case. So let's also clone this repository. So we'll just take that, go here, and do git clone, paste it. Okay, so all three repositories have been cloned. There they are. So we'll now build the Apex repository. So let's go into Apex core. And if we do an ls, you'll see there's a number of directories and files there. The file that actually controls the build is this file called pom.xml. It's a XML file that has, it's a fair-sized file that has lots of information about dependencies and how to build the code. So you don't have to explicitly reference that file. Instead, to build it, we run the Maven command mvn clean. Clean is actually not necessary in this case because we just cloned the repository. But if you've done a few builds before, the clean will get rid of the old artifacts. And then we do an install, clean install, and then a -d skip tests. So skip tests, what it does is it skips running the unit tests. There are many unit tests and it can take several minutes to run, and we don't really need to run them. So this is a good option to add. So a word about the install. It's not actually installing anything into the system directories, so you don't need to be root. You don't need super user permission. What it's doing is installing the artifacts of this Maven build, things like POM files, Java jar files, and so forth, into a local repository under your home directory. So typically under your home directory there will be a directory called .m2, and inside that is where this installation happens. Okay, so let's go ahead and do that. This can take a couple of minutes because Maven will go through that pom.xml, find all the dependencies, and then download the dependencies from the net into your local repository. So in this, while that's happening, let's go over to a different console. And let me show you that M2 repository that I was talking about. So if you do an ls-l.m2 in your home directory, you'll see this. You might see a couple of XML files, but you'll see the subdirectory called repository. And if you do an ls on that, you'll see a huge number of directories. So these are all the dependencies that Maven determined it needed as you were building various Maven projects. Okay, so let's go back to core and see. Okay, it's still continuing. It should be close to finishing. Let's give it a few seconds. The build actually has many features for checking the code style, for running unit tests, and so on. All right, so it's finished, and it tells you that it took 1 minute and 36 seconds. And when it okay, so let's do the same thing with the Malhar library. So Apex Malhar. So here we see contents of that directory and the same pom.xml that I was talking to you about. We run the same Maven command here. This one takes maybe about 3 or 4 minutes. So let's move over to our other console, and let me show you a couple of other things. Let's step into our work directory where we've been doing all our work. If we search this examples directory, find in examples, dash name new app, there it is. There's a file called new app under examples, tutorials, top N words, scripts. So that's the script that will generate a new Maven project for a new application. So let's go ahead and copy that over. And if I edit it, you'll see that apart from a couple of variable settings called name and version, all it is just running a Maven command. So Maven has this feature where you can specify an archetype, and an archetype is just a template for a new project. With the appropriate parameters, when you run the archetype command, it will generate a whole new Maven project for you. That's pretty handy because you can actually, the structure of directories that Maven expects, you don't have to remember it. It will automatically create it in the right form for you. And you can also have it populate that directory structure with some files. And in this case, that's what will happen when we run this command, it will not only create a new project, but it will also create a couple of Java files with a ready-to-go application. It's a very simple application, just generates random numbers and writes them to the console. So it has like two operators, one the random number generator, and the other is the operator that writes to the console. Okay, this is an older version of the script, and currently the version of the archetype is 340, so I'm going to change 330 incubating to 340 and remove that dash incubating suffix. Okay, so let's save that file, and we'll be able to run it to generate a new project in just a second. Let's check what happened with the build of Mulhar. Okay, it's still going. Let it complete. And meanwhile, this application that we'll be building today, recall that I mentioned that it reads from an input directory and then writes to an output directory. Well, those directories are configurable, and in this particular instance, they are under /temp, but not /temp of your local file system. These applications actually read from HDFS, Hadoop's distributed file system. So we can run some HDFS commands to look at those directories. So the common one is HDFS DFS -ls. And then if I give it the path /tmp, it should show you the contents of tmp. Okay, there's only one subdirectory called test. Now, keep in mind that this is under HDFS file system, so it's not local, as I said before. So if we just do a plain ls of /temp, we'll get a whole different set of contents. So this is the /temp on the local file system. All right, so let's run that command again on the test directory, temp test. So here it should print out a couple of subdirectories, one called input dir and the other called output dir. And if I do an ls on each of those, it should print nothing because there's no files there. Okay, there we go. There's nothing in there. So the input dir is the directory where we'll drop a data file, which will be picked up by the application and processed, and it will write its output to the output dir directory. Now, in order for all of this to run, you have to have Apache Hadoop installed. So you can just go to the Apache website and download the most recent version of Hadoop. I think it's 2.7.2 or something like that, 2.7.3 maybe. And then follow the instructions on the website on how to install it. So once you've installed it, you'll also need to start the daemons. So HDFS and Yarn consist of a number of daemon processes that need to be running in order for all this to work. So one way of checking that is to type JPS. So if you type JPS, JPS is just like the PS command on Unix, but it produces more user-friendly output, and it also limits its output to just the Java processes. Notice that we have a resource, in addition to the JPS process itself, we have a resource manager running, we have a data node running, we have a name node running, we have a node manager running, and a secondary name node running. So all of these processes need to be running. If you follow the instructions on the Apache Hadoop website, it will tell you how to start it up. So in my case, I have a local variable called a shell variable called $H, which tells me where Hadoop is installed on this machine. I installed it under software Hadoop-272 in my home directory here. And let me show you the command that I ran. Okay, so under that home directory, there's a subdirectory called sbin and scripts called start yarn and also start DFS. So if I just do an ls on that pattern, you'll see the scripts. So you need to run start dfs.sh. That starts the distributed file system daemons. Once that's going, you need to run start yarn. Yarn is the resource manager. Once you've done that, you can verify, and this is also in the instructions for Hadoop, you can verify that things look good by going to this location, just localhost and port number port number 50,070, 50070. If you go there, you'll see this page. It has lots of information about your installation of HDFS. It also tells you whether security, Hadoop supports Kerberos-based security. It tells you whether security is on or off in this case. It also tells you whether safe mode is on or off. So this is really important for safe mode to be off. Safe mode is initially on when the daemons come on, and then they do various checks on the file system to make sure everything is okay. And during that time, safe mode is on. Once everything is determined to be in good shape, safe mode is turned off. So if safe mode is on, then many of these commands to write to the HDFS file system will not work. So it's important to make sure that it's off. So this is for HDFS. To check the console for yarn, you go to port 8088, localhost colon 8088. So if you go there, you'll see this kind of a page. Notice that it's showing you the list of applications, and currently there are no applications. When we actually run an application, you'll see additional rows being populated on this table. One important thing which I'd like to point out is if you go to Tools and then Local Logs, you'll see a lot of log files here. So if something goes wrong, this is where you should go to troubleshoot things. So typically the resource manager log file is the one that's most useful, and here's that file. You can take a look at it. You can look at it on the screen here, or you can actually navigate to that location, because this is just a single node cluster, and take a look at it. The user logs directory has one directory per application, within which there are subdirectories containing log files specific to that application. And these are all applications that I've run before. That's why they're still here. They don't get cleaned out automatically. And you can see they're all old. There's nothing with today's timestamp. Once we run today's application, we should see a directory here with the appropriate timestamp. So let's go back here and see if Malhar is finished. And indeed it has. It took about 5 minutes. So let's now run our new app script. So because it's a shell script, I can just run bash new app. Okay, so it's finished. If I do an ls, you'll see it's created this my Apex app directory. That's the new project. So let's step in there. And here you see it's very few files here. There's a source subdirectory that has all the source files, and the pom.xml, which we've seen before. We could actually build this application, and it will build, and we can run it. We can look at what Java files already exist here. So if I run this find command, it shows me the Java files. And as I mentioned before, here's the random number generator operator. And here's the application file. There's also a unit test called application test.java. The source files are under source main java.com example my Apex app. So let's navigate to that directory. And do an ls-l, and here we see the two files. So to save time, I've actually prepared some source files for our sorted word count application, and they're actually in the examples repo. So let's copy over those files. If we do an ls of ~tutorials/examples/top-n-words/webinar, that's where the files are. And there you see there's a whole bunch of Java files, and there's also one XML file. That XML file is a configuration file for this application and needs to be placed in a different location. So for now, let's copy over the Java files to here. And if I do an ls-l, here you see the entire list of files, including the original ones that we've retained. So in a single project, when you build this project, it will create a package file with a .apa extension. Within the package file, there can be multiple applications. So in this case, there will actually be two. One is the original default application working with random number generators, and the second one is this word count application that we've just added the source files for. Okay, so let's now move up a few directories. And under main, you'll see a subdirectory called resources. So if you cd to there, there's this meta-inf. And if we look here, we have a file called properties.xml. So this properties.xml contains configuration values for all of the applications in this project. If you want to customize these properties additionally on an application-by-application basis, you can have a file here that's named properties- and then the name of the application .xml. So that's the file we saw earlier over here. So I'm going to copy over that file to this location. Okay, so there's the previous copy command. Instead of star.java, I'm going to copy star.xml to the current directory. And here we see the two files. We'll look at these files and what they're configuring in a few minutes. Meanwhile, let's come back to the top level of our project. And here we have, we're now ready to build this application. So let's build it the same way we built the other repositories, with one minor difference. So here, instead of install, I'm going to say package. So what this does is it simply creates the artifacts locally, but doesn't bother installing them in the Maven repository, the .m2 directory that I was talking about earlier. Installing is necessary for libraries that might be needed by other projects, but for individual projects themselves, individual applications, there's no reason to install. So package is adequate. So what this will do is, notice that in the list of directories here, we only have source. There's no other subdirectory. After we run this command, you'll notice it'll have a subdirectory called target. And that target directory will have all of the artifacts, including this .apa file that I was talking about, which is what we'll need in order to run the application. Okay, so let's go ahead and run this command. Puts out a couple of warnings, but they're not serious. You can ignore them. Should finish pretty quick because there's not a lot to do. Over here, there it goes. It's finished in about 20 seconds. Now, as I mentioned, you should see the target directory. There it is. And there's the list of things that it generated. It generated a lot of artifacts, put them all into subdirectories under target, and at the top level, it's created this APA file that we will use. Okay, so now we're ready to launch the application, and in order to launch it, we need to use a command line tool that's in the core repository called Apex. Okay, so here we are. If I step into, or actually I can do a find on Apex core and give it the name Apex. There it is. Under Apex core engine, source, main, scripts, Apex. That's the script. So you can go ahead and run it, and it will give you a prompt and work like a mini shell. Within it, it has built-in help. It also has built-in history support, so you can scroll up and down through your Apex commands. So let's go ahead and run that. Okay, there we go. It prints out a short message giving the version that it was built from and the branch and a timestamp, and then you get this Apex prompt. So here it has a lot of commands, and there's built-in help, so if you type help, it'll show them all. But in our case, what we want to do is launch the application. So let's do, you can do help followed by the command that you want more information for, and that's launch. And here's the help for that command. So you just say launch, and then you give it the app package file. That's the APA file. So that's one of the things that you can give it as an argument, and that's what we'll be doing. There's a number of properties that can be used to configure individual applications, and if you need to supply custom configuration properties, you can use this -d option and then give it the name of the property, equals, and then a value. Those are usually the two most common options for launching an application. Okay, so here we can also run a command called list apps, which shows the list of running applications. Currently there aren't any, so that's why you get this empty array back. Okay, so let's go ahead and launch. Our application is under My Apex App /target, and then the file has the .apa extension, and there's only one such file, so I can use a wildcard APA. It should chug along for a little bit and then come back and print out the application ID. Oh, actually it prompts you. As I mentioned, you can have multiple applications inside an APA package file. So in this case, there's two, so it wants to know which one you want to run. So here you give it 2, because the sorted word count is what we actually want to run. Okay, so in a minute or so, we should see the application ID. There we go. So it shows you that you have this application ID. So this long string is something that you should keep track of, cut and paste it somewhere, because if you need to troubleshoot in the log files, that's the ID that you need to look for. All right, the prompt also changes, showing you that you're in the context of that application, but you can still run any command you want. So if we did the previous list apps command, it should show you a running application, and there it is. It shows you the start time, the ID, the last portion of the application ID shown here is what it prints here. ID is 10001. The name of the application, its current state, tracking URL, and final status. Once the application is terminated, this thing will say killed or terminated or something like that. Okay. Recall that we mentioned that in the Yarn console, you should be able to see the running application once you have something running. So let's refresh this page and make sure we see that. There it is. So we see the 0001 application, the name, the application type, the start time, the queue it's on. Finish time, of course, is not meaningful because it's still running, and everything looks good. So if you go into this tools, like I was showing you for the logs, and then go into the user logs, you should now find a subdirectory with this application ID that contains the logs for the individual containers. Okay, so let's go back here and let's drop the data file for the application to process. So under share here, I have a text file called Pride and Prejudice. This is an ASCII text file of the Jane Austen novel called Pride and Prejudice, downloaded from the Gutenberg project. So we'll copy over this file to the HDFS input directory that is being monitored by the application. And the way we do that is we say HDFS DFS -put share/Pride and Prejudice, and then the destination is going to be tmp test input dir. Recall, input dir is where we need to drop the input files. Okay. Now let's do a hdfs dfs-ls of that directory, and we should now see that file there, the input file. Okay, so the application is now running, processing that data, computing the word counts, and finally sending the result to the final operator in the DAG to write it to the output directory. Usually it takes a couple of minutes for the output file to show up. Let's see if it's already there. If we do an ls on the output dir, we should see some output. There it is. It's the file with the same name, but it's in the output directory. So notice that the size of the output file is much smaller than the size of the input file, which is about 700 megs. The output file is only about 89K. And that makes sense because the output file only has the pairs, the words and the frequency counts. So let's look at the output file. I'm going to just cat the first few lines because there's a huge number of lines there. So if I do this hdfs cat command, hdfs dfs-cat, it will work just like the Unix cat command and catenate the contents of that file to your console. If we connect that to the output of wc, you'll see how many lines it has. It has 7,000 lines, so there's about 7,107 individual words in that novel. So instead of, I don't want to dump all of that on my screen, so I'm going to pipe it to the head command, which only prints the first few lines. Okay, there we are. So the most common word is the article the, as you would expect. There's 4,218 occurrences. And then we have these various conjunctions and prepositions, which are very common in English. So our application has now run successfully, and we can actually kill it. Let's see. So in the Yarn console, it continues to show the application as running. There's no change. And we can go down to this console where we have the application running. Let's run that list apps again. We see the application is still running. And here I can run kill app, and that will kill the current application. If I now do an ls, or list app, sorry, you should see this list, but now it shows the state as killed and the final status as killed. So the application is no longer running. And the same should be the case in the Yarn console. So if I refresh the page, there we go. We see the state as killed and the final status as killed. Okay, so let's quickly look at, we can exit this command line tool by typing exit. Let's now step into these code and take a quick look. if we go into source and then main, resources. So here we have, let's look at this properties.xml. So this thing is an XML file. So here, this is just a comment, and this is also a comment. So each application that's running on Hadoop needs to have what's called an application master. That's another process potentially running on another node. So this configuration option lets you limit the amount of memory that the application master uses. So here we're saying the attribute master memory MB is limited to 1024. So the application master is allowed to use no more than 1 gigabyte. So if it goes beyond that, your application will die. These are the properties for that random number application we talked about. So the number of tuples emitted per window is configured to be 1000. And the string that it prints out is just hello world and the random number. So this is not especially interesting for our application, so let's look at the other one. Sorted word count. And here we see a number of interesting things. So I've commented out this property, which allows you to pass additional parameters to the JVM that's running all of the operators in your application. So for example, if you want to pass a different log4j properties file for configuring logging, you do it this way. This application also needs to know how to split the words. So what's a word? Well, the way the word splitter works is it has a regular expression called non-word str, and it uses that regular expression to determine what forms the boundary between words. So here I specify the expression as being one or more instances of punctuations or white space. Okay, so that's what that regular expression is saying. And you'll notice that in all these cases, the operators are configured in a very similar way. You have dt.application dot, and then the name of the application, and then dot operator, and then the name of the operator, and then the name of the property. So this is the way most properties are configured. So if we go down here, you'll see the input and output directories are configured. Here's the temp test input dir that we've been looking at. That's where we copied the input file. Here's the temp test output dir where the results were found after the application completed. Here's again that master memory configuration to limit it to 1 gigabyte. This is actually redundant because it's also present in the other file. And here we're also limiting the amount of memory used by all operators to 128 megabytes. So this is a way, if you know that your operators shouldn't need more than a certain amount of memory, you can limit it this way. That way you don't waste cluster resources for one thing, and you also get early detection of problems, because if the operator ends up using more memory, it'll get killed by the system, and then you can figure out why it took so much memory. Maybe you had a memory leak or something like that. So this buffer memory is sort of an internal memory that it uses, and that also is being limited to 128 megabytes. Okay, I'm almost done. If we now step into the source directory, let's look at application word count. And here's this populate DAG that I was talking about. So here we create a line reader by saying dag.add operator and then a new line reader. And then similarly for word reader, window word count, we just create new objects, pass them into this add operator. The same operator will be returned. And then we create the streams. This is the name of the stream, and it connects the output port of the line reader to the input port of the word reader. And here's the control port that sends the end of file indication. That goes from the line reader's control port to the file word count control port. Excuse me. And we similarly now have the other streams assigned the same way. Okay, it looks like I've run out of time. Doesn't look like there's any questions either. So thank you all very much for attending the webinar. And happy apexing. Goodbye.